I want to welcome you all to today's episode of Amino Tutoring. There is something very interesting I would love to share with all of you. For those who have played around mathematics, I don't know if you have observed that mathematics is just beyond problems and solutions. If you look at the behaviors around math problems, you can see other trends that applies to life. You will see motion, you will see actions and consequences. Now today, I want to use this mathematical tool called GeoGebra. GeoGebra, you can actually see this tool in the Play Store. You can download it, install, and you can also use it to teach mathematics to your students. Now this is just the graphing calculator that I'm using. Now we want to take a look at the behavior of the parabola of a quadratic graph. We want to look at the behavior. You know, for every quadratic equation is of the form ax squared plus bx plus c. That's the form of a quadratic equation. Now, the a, b are the coefficients of x squared and x, and then the b stands to be the constant. Now, what role does this element play with regards to the graph of a quadratic equation? That is actually what we want to check today. We want to see the behavior. We want to understand what can you conclude just from looking at the quadratic equation problem, even before plotting the graph. Now, I want to make this very easy for us. This is what we have on our screen. Now, this is A, this is B, and this is C from what we have in our quadratic equation. Now, this is our graph. Now, at this level, we cannot get the roots of this graph because there are no numbers attached to this coefficient and the constant term. So we cannot get the roots. There is no root to this equation already because we have not formed any equation here. So at this point, this is just a graph. Now we are going to tilt this coefficient and the constant term and see the resulting consequence on this very graph. We are going to start with A. If A becomes, let's say, 0, what happens? Don't forget that we say for us to have a quadratic equation, A must not be equal to 0. Because if A becomes 0, the x squared disappears. And when x squared disappears, it becomes a linear equation. And when it becomes a linear equation, you are expected to have a linear graph, which is going to be a straight line graph, just the way we are seeing this one. Let's move A again. If A becomes negative, if A goes negative, and the smaller it gets in being negative, it shrinks downward on the graph. You see that the parabola is facing down. If it becomes positive, it goes up, and the bigger it gets, the more it shrinks. Now let's come back to B. Let's leave it at 1. Now let's come back to B. If B gets too big towards the positive side, your root tends to be in the negative side. You tend to get negative roots in the quadratic equation. When you now get negative, you tend to get positive roots. Now, where the magic falls so much is on the C. When C becomes too positive, you see that is going up, 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 up. You see what is happening? Now, the bigger that C gets, the higher the possibility of not getting a real root at all. At this point, you can be expecting a complex root, because for you to get a root, this must cut the x-axis such that these 2 points, A and B, becomes your root. But when it gets too big, there is no root anymore. When it gets here, you see the root. The same thing with our B. Let's bring this one back to 1. Now see what happens to B. See where the root is. The root is between 0 and a negative result. If we get to this side, it becomes A and B. So just from looking at the coefficient of A and B of a graph and the constant term, you can be able to deduce the nature of the graph, how the graph will look. If C becomes too big, there is a high possibility that you will not get a real root, whether they are equal or unequal, but rather you should be expecting a complex root with the imaginary number. I hope this video helped you understand some few things on how the quadratic graph can actually behave based on the parameters surrounding the question. There is a lot to learn. Just stay put, share this video to your friends, your family, to whoever you think this video is going to help. And for this math tool, I think it's good you get it and pay attention to how it's used. This will help you so much in solving problems. You can use it to solve differential equation, integration problems, you can use it to do statistics, and many other things. Thank you very much for watching.